vectors in the film, they're the same thing. True. Put true down there. Jordan, number 1.
We're all going to get number 1 right.
Pythagorean theorem, subtracting vectors, angles clockwise, angles counterclockwise, resolving a vector. Here's the quadrants. Name the quadrants. Here's a question about radians. 2 pi radians equals 360 degrees. Eli, ICE, series LC circuits. Calculate x of L, calculate x of C. Z stands for impedance. Calculate Z in a series LC circuit. Now, if I just say LC, there are no what? Resistance. There are no losses. It's ideal. Find total current. Find the voltage across the inductor. True power question. True power in an ideal LC circuit is what? No resistance. True power is going to be what? The only thing that dissipates power is resistance. In an LC, pure LC circuit, there's no resistance, therefore there's no power dissipated. It's all returned back to the circuit. Therefore, true power is 0. 0 watts. That's the same question we have in the handout. And a lot of numbers, some of us missed it. Apparent power. How do we find apparent power? Just like we used to. Pi. P is equal to what? I times Z. That's the way we used to do it. So apparent power is I times Z. Okay? Okay, so that's...
Is it measured in VA or is it measured in...
Yep, it's measured in VA, volt amps. It's not even given watts. Because it's not true. It's apparently that's how much power it uses, but it's not. But it's not dissipated. It's returned back to the circuit. Find Z in a series LCR circuit. So this has got R in it now. So when I have R and it's series, and I want to find Z, what do I do?
If you're what now? In series, Z equals square root of resistance squared plus XL minus XL. XC squared.
I do it in 2 steps. First, I take this and do what?
Flip him up there.
Subtract it. And then I do what?
Make your box.
That's my Z right there. Okay? So, yeah. So, Z is equal to the square root of R squared plus, in this case, it's going to be X of L minus X of C because that's the big one, squared. Okay? So, I'm going to subtract this one from this one. That takes place right there. Then I want to find the hypotenuse, so that I use Pythagorean theorem. That's what this is, isn't it?
Mm-hmm.
Okay? What does this represent right here?
Theta.
Theta, which is the what between the current and voltage?
Angle.
Phase shift between the current and voltage. And is it going to be positive or negative? Positive. Negative's down here. Positive. See, in series, I put X of L up here. In parallel, I use currents. I don't use resistances. I got to use currents to solve parallel. And I put the IL down here, IC up here. I reverse these with currents, remember? Okay, so that theta represents the phase angle. Now, parallel LC circuit. What's the reference in parallel? What's always the same in parallel? Voltage. What's the reference in series? Current. That's 2 of the questions right there. Here's an ICE question. Here's an Eli question. Find I line. Find Z. Will the circuit be capacitive or inductive? Find the resonant frequency. How do I calculate FR? 1 over 2 pi times the square root of L times C. Be sure you can find X of C, you can find X of L, you can find the resonant frequency, you can find Q, bandwidth, all those things with your calculator now. So resonant frequency is what? 1 divided by 2 pi times the square root of LC. So be sure you can do, I think there's at least 2 or 3 of these right here. You're going to do a series one, you're going to do a parallel one. I know there's at least 2. And in series and parallel, I use the same formula. Okay, how do I find Q?
XL over R,
XL divided by R. How do I find bandwidth?
FR over Q.
FR divided by Q. What else do we have to find? Line current, tank current. How do I find Z in parallel?
Z equals energy applied over amp
Yeah.
total.
That's one way. That is a way. In parallel, this is probably the easiest way right here. I simply take Q and multiply times the XL or the XC that I have in the circuit. What's your tank circuit? One time I had a guy in here, last year or the year before, anyhow, he was a tank driver. He drove those Abrams tanks over there. And then one of the guys I had in here, got this semester, it's in another class, I think. He transported the tanks on the big flatbeds, to get them somewhere. And he was saying that when they had the tanks on the back, they wouldn't ever shoot at them, wouldn't bother them. But when they were coming back, they'd already unloaded the tanks, and they were on the way back, they'd shoot at them, down the road again, Okay, we're fixing to do a parallel, and that's what this film's all about right here. And we're gonna, this film is gonna review this stuff right here, okay? And, because it's parallel resonance. Now, what happens at resonance now?
That's when they both,
X and L.
and L, means purely resistive.
They have equal values and calculate these small numbers and
Okay.
curves and
All right. Exactly. Now look at this guy right here now. Look at this first list right here. So impedance in impedance in series resonance is minimal. Because the two cancel each other and all I got left is a little what? Little resistance, little R. Current in the circuit is, since I have minimum opposition, current's going to be what? Max. Impedance at resonance is resistive. That's the only thing that's left. X of L, X.
I covered my anxious on the slingshot. I had to pick my buddy up in Shreveport and his truck broke down.
His truck broke down.
Yes, sir.
Pick your buddy up in Shreveport. Okay. What was wrong with his truck?
He don't know yet.
Just didn't start? Didn't,
It's 6 pounds diesel.
that Ford 6-point diesel?
He's had problems with it before.
They have had tons of problems with that thing. Of course.
EGR,
Huh?
the EGR, has he blocked it?
Mhm.
He's about to blow that gasket if it got too hot. I know.
He don't really take care
I
of
have
it.
put, mine is Chevrolet, that Duramax diesel. I put 2 sets of fuel injectors in already.
Mm.
And that's a 203 engine. But that 03 engine, they had a lot of trouble with it. They fixed that in 04, but anyhow. I mean, that thing's almost $5,000. Put a set of fuel injectors. You got to pay for the whole thing. Buy the injectors and have them put in there. Well, anyhow, General Motors is paid
Most
for.
of the work on that, you gotta take the whole cab off.
Yes. Oh, no, not on this one, not on mine.
On the Ford you do.
On the Ford, you got to take the cab off.
It's easier.
Yeah. Well, that's like when you do a fuel pump. It's easier a lot of times to take the bed off, isn't it?
You got it, yeah.
Okay, well anyhow, here's the formula for impedance, here's the formula for Q, for bandwidth, for FR. Now, parallel is what we're being talking about. Look over here, impedance, series, minimum, but parallel is what? Maximum, backwards. Current. Well, because we've got maximum opposition, what's the current going to be? Minimum. Resistive again. Okay, anyhow, let's Last one, guys.